functions. So here's our formula for exponential growth. This occurs when a quantity exponentially increases over time. So we have our variables a, which equals the initial amount, r is the growth rate, and t is the time. So after reading the word problem, we can pull out some values. So with this 1800, since it's the original value, it's the same thing as the initial amount. So we have 1800 will be our a value. Then they tell us that it's increasing by 7% each year. To change a percentage to a rate, we'll just move the decimal over twice. So this is going to be our r value. And they told us that the value of the investment will be after 15 years. 15 is our t. So f of 15 is equal to a, which is 1800, times 1 plus 0.07 raised to the power of 15. So this is equal to 1800 times 1.07 raised to the power of 15. That's 4,966.26. So we'll add a unit of dollars, box our answer. So after 15 years, the investment will be $4,966.26. For the next example, in 2002, there was 972 students enrolled at Oakview High School. Since then, the number of students has increased by 1.5% each year. Write an exponential function to model the situation, then find the number of students enrolled in 2014. So we have 972 students increasing by 1.5% each year at a time from 2002 to 2014. So 2014 minus 2002 is 12 years. So our function f of 12 equal to 972 times 1 plus 0.015 raised to the power of 12. 972 times 1.015 to the power of 12 equals 1,162 students. So after 12 years, there's 1,162 students enrolled at Oakview High School. So the next formula for exponential decay occurs when a quantity exponentially decreases. So it's very similar to exponential growth, but this time the decay rate will be negative, so we'll subtract it from 1. Now here are two word problem examples using exponential decay. An investment of $12,000 is losing value at a rate of 4% each year. Write an exponential function to model the situation, then find the value of the investment after 9 years. So here's our initial amount. Here's the decay rate. And here's the amount of time. So f of 9 equals 12,000 times 1 minus 0.04 raised to the power of 9. That's 12,000 minus 0.96 to the power of 9 equals 8,310.41 cents. So after 9 years, the price will decrease from $12,000 to $8,310.41. So for the second example, Mark bought a brand new car for for $35,000 in 2008. If the car depreciates in value approximately 8% per year, write an exponential function to model the situation. Then find the value for the car in 2015. So in 2015, seven years have elapsed. So our t value, so when the time has 7 years, 35,000 times 1 minus 0.08 to the power of 7, 3,000 times 0.92 to the power of 7 equals 19,524.63 in dollars.